All right, so here we have a question that they saying what is the relation between sine, where is it? Sine of an angle, theta, and cosine of theta. And briefly, I'll go over this table, and then we're gonna drive and then see what is the relation between these two. First of all, let's draw this table. I'll show you the table quickly here. Not like that. Let's make it a bit darker. Okay, so stable. These are the degrees: 0 degree, 30 degree, special angles. Not the 0 one and 91. I'm not gonna explain it, but I'm gonna put on a table here. 45, 60, and 90. And we want to talk about sine of these 30, 45, and 60. Cosine of these, tan of these. And also for those who they want to know, there's cotan. Cotan, but we're not going to talk about that. That's inverse of tan. As simple as that. So sine of an angle, let's say 30 degrees, right? What is sine of 30 degrees? How we get there, see, if I draw 30-60 triangle, I'll draw it here, 30-60 triangle. This is 30, that's 90 degrees. This is 60. Cool? Relation between this special triangle and in the past, from the past, we know that if this is x and the hypotenuse for this triangle, which one is x? First of all, you need to distinguish this. X, I'm labeling the shortest leg. And shortest leg is this leg, which is opposite to the smallest angle, which is this angle. So I'm labeling x. I'm going to start from there. It doesn't matter what it is. Just let's say x. If that's x, or whatever this is, hypotenuse is twice as much as that one. As easy as that. 2x. So if this is 6, x is 6, that hypotenuse is 12. If x is rad 3, hypotenuse, this one is 2 times rad 3. So I'm going to write a couple of them. So if that's 2, that's 4. If this is 10, that's 20, you see? And then how about relation between shortest leg and this middle one, which is opposite to 60-degree angle? Again, from the past, from special triangle, we know if this is x, shortest one is x, opposite to 60 is rad 3 times that, which is rad 3x. So if this is 2, then this is rad 3 times 2, which is 2 rad 3. And if this is 10, then this is rad 3 times 10, which is 10 rad 3. Okay? Now I'm going to drive the results and I'm going to put them in the table. So what is sine of 30? Sine of 30, isn't it opposite over hypotenuse? That's 30, opposite of that one, over hypotenuse. Like x over hypotenuse is this one, 2x. X over 2x. Or you can say 2 over 4. Right? If I go with variable x over 2x, if you simplify, x and x cancels, you get 1 over 2. And if you pay attention, cosine of 60 is equal to, now 60 is this one. Cosine of the 60 is adjacent over hypotenuse. That's adjacent. Over hypotenuse that one. So it's going to be x over, again, 2x. Now look at this. This is tricky. This is special. And if you do sine of 30 and cosine of 60, you get same thing. X over 2x is equal to 1 over 2. Basically, in a right triangle, complementary angles are congruent. Sine of one of them is congruent. I mean, for complementary angles, sine of one of them is equal to cosine of the other one. Like sine of 60 is equal to cosine of 60. So these are equal. So I'm going to write it here. That's why sine of 30 is equal to cosine of 60. So this is the result. And if you do this for the other one, 45, 45 too, you're going to get the same thing. So, and then if you do for cosine of 30, let's do cosine of 30. What is cosine of 30? Even I'm going to start with sine. See, for this one, I started with sine of 30, sine of 30. Now I'm going to talk about sine of 60, and I'll show you that's equal to sine of 60, and I'm going to show that equal to cosine of 30, because 60 and 30 are complementary, they add up to 90. Sine of one of them would be equal to cosine of the other one. Sine of 30 is equal to sine of 60 is equal to what? 60 is this one. It's equal to opposite or hypotenuse, right? Opposite is rad 3x over hypotenuse 2x. So you get what? X and x cancels, you get rad 3 over 2. So remember, sine of 60 is equal to cosine of 30 equal to rad 3 over 2. That's the number. You need to memorize this. In this case, this is the number. You need to memorize that. Let's highlight that. Okay? So there's one more. I'll explain. I'm going to put them in the chart. And we're going to come up with a conclusion. So third one. Oh, that's a fancy color. 45, 45. In this case, we don't have it. So I need to draw a 45, 45 triangle like this. 45. That's a special right triangle, so that's 90. Therefore, this is also 45. So they add up to 180. So if this is x, what is that one? What is if one of the sides is, these are called legs also. If one of the legs is x, what is the other leg? That's also x. Why? Because it's isosceles triangle also. Because these triangles are same. Therefore, opposite to these angles, these sides are same because it's isosceles. So again, from the past, we know if this is x, that's rad 2 times x. Okay. Now, so let's drive that. Cosine of 45. Let's start with sine because we always start with sine. Sine. So, sine of 45 is equal to, let's pick this 45, opposite or hypotenuse, even though it doesn't matter, x over rad 2x. That same as, it cancels, it becomes 1 over rad 2, x and cancels, right? And if you get rid of rad 2 from denominator by multiplying by rad 2, top and bottom, you get rad 2 over rad 4, which is 2. And if you do the cosine, it's going to be the same thing. Cosine of 45 over is equal to, cosine of 45 is equal to adjacent over hypotenuse. I'm picking the same angle. Adjacent is x over rad 2x. See? Adjacent over hypotenuse, rad 2x. You see they're both same. Equal to eventually 1 over rad 2. And if you simplify, rad 2 over 2. Therefore, sine of 45 is same as cosine of 45. And it's equal to rad 2 over 2. So let's put this into table and come up with a good conclusion. So if you look at these, this is what we got. We got sine of, okay, that's good. Sine of 30 is equal to rad 1 over 2. That's same as with the complement. Complement of 30 is 60. That's equal to cosine of 60. That's right, 1 over 2. And we figure sine of 60 is rad 3 over 2. That's same as cosine of the other one. Cosine of 30, which is rad 2 over 2. And sine of 45 was rad 2 over 2, same as cosine of. Complement of 45 is 45. So cosine of 45 is again rad 2 over 2. So that's about that. And then tangent is always, I'll go a little bit quickly about this one because I'll tell you what to do. Tangent is always, here, just the formula, tan of an angle, like theta, is equal to sine divided by cosine. Sine of theta divided by cosine theta. That can be driven with the formula that you had. If you do this, sine of theta is equal to opposite over hypotenuse, opposite over adjacent. And you see that same as sine theta over cosine theta. So basically, here again, you can find it. Tan of theta, tan of 30 equal to, for example, tan of 30. What is that? 30 is here. What is tan of that? It's going to be opposite, just x over rad 3x. So it's going to be x, come on, x over rad 3x. X and x cancels, it's 1 over rad 3. And if you get rid of rad 3 by multiplying by rad 3, you see that's rad 3 over 3. That can be driven also using this formula. Sine of theta divided by cosine of theta. Basically this. Tan of 30, this tan of 30 can be calculated from this divided by this. So we got what? Rad 3 over 3. If you do that, 1 over 2 divided by rad 3 over 2, you get rad 3 over 3. And then same thing you can do here. What is tan of 45? That's another way of explaining. So remember, I didn't explain it on a paper this way. Tan of 45 is what? You can say, isn't it? Tan of 45 is equal to opposite over adjacent. Opposite over adjacent. So it's x over x, which is equal to 1. Cool? So that's 1. Hey, 1. So you can find that here also. Tan of 45 is sine divided by cosine. Means rad 2 over 2 divided by rad 2 over 2 is 1. And then that's one more thing. What is tan of 60? Tan of 60. That's equal to, over here, it's going to be, tan is opposite or hypotenuse, and 60 is 1. Opposite is rad 3x over, opposite over adjacent. Rad 3x over adjacent. Adjacent is x. That's equal to rad 3. Right? Rad 3x over x is rad 3. X cancels. So we got that. That also can be calculated, right? So sine of this 60 divided by cosine of 60 is equal to rad 2. Here, conclusions. From here, we figured one of the conclusion is that sine of 30 is equal to cosine of 60. Sine of 60 is equal to cosine of 30. Sine of 45 is equal to cosine of 45, complement of that. And also even more than this, we can expand, I say sine of, even let's say whatever angle, these are special angles. If you pick any angle, sine of 10 is equal to cosine of what? What is complement of 10? Even though it's not in this integrated math book, they don't talk about this, but we can conclude that from here. Sine of 10 is equal to cosine of 80. Or sine of whatever, give me a number, like 5 is equal to cosine of 85 degrees. Cool? That's fine. So that's one of the conclusion. And other one is this. If you do this, there's a formula in trigonometry, you're going to see that. Sine of an angle, the theta, to the second power, plus cosine of an angle, like theta to the second power, is equal to 1. I'll show you that here. Let's say sine of, example, sine of 30, we already found that, to the second power, okay? Sine of 30 to the second power plus cosine of the same one, 30 to the second power. See what we're going to get. I said it's 1, should be, let's see if we're going to get 1. What is sine of 30? It was 1 over 2 to the second power. What is cosine of 30? Rad 3 over 2, all that to the second power. Is that going to be 1? See, 1 over 2 squared is 1 over 4. Rad 3 squared is going to be 3 over 4. If you add them, you get 1. So that's equal to 1. So therefore, so another conclusion is, always sine of an angle to the second power plus cosine of an angle, any angle to the second power, is equal to 1. Now that's concluding this.